All right. So for our third application, I want to look at how to get a tangent line when we don't know what the point of tangency is. We just have this external point. And believe it or not, this is actually kind of what we were talking about. Remember when we said that in space travel, they kind of slingshot around planets, and you got to make sure that you get out of the orbit at the right time so that you're aimed at your target. Okay? Well, here's our orbit, and here's Earth over here at the point 2,3. And if we don't leave at the right spot, if we don't have the right point of tangency here, we're going to be in trouble. Okay? So, how will we go about doing this? Let's think about our process. Okay? First of all, let's think about our tangent line. Okay? And let's find the equation of this line in terms of A. All right? So find the tangent line in terms of A. Okay? So, how would we do this?
Find the derivative and put A in.
Well, hang on, forget about this curve right now, so we're not going to get a derivative yet. We just have this unknown point A and A squared, because this is the function x squared. So if x is A, then y is A squared. And we want it to hit the point 2,3. So forget that we even have that parabola there. How would we get the equation of the line?
Slope?
Okay, yeah. How do you find the equation of a line? Get the slope and use a point, right? So our slope is the y-coordinate minus a y-coordinate. So let's say a squared minus 3 over x-coordinate minus x-coordinate, a minus 2. Okay, there's our slope. Now, we want this to hit the point 2,3. Okay? So, I'm going to use point slope form to get the equation of my line. Y minus the y coordinate, I'm going to use the point 2,3. So y minus 3 equals my slope, a squared minus 3 over a minus 2, times x minus the x-coordinate, x minus 2. Okay? So that right there is my tangent line. I'm not going to simplify too far yet. You could. It's just preference here. So a squared minus 3 over a minus 2 times x minus 2, and then I'm just going to put this plus 3 at the end. Okay? But let's think about that. What do I want that line to do?
Intersect.
Okay? I want it to intersect the curve y equals x squared, right? And I know its slope has to equal...
Do you set x and y equal to the a and the a squared?
You do x for x squared is equal to that.
Okay. Well, there's a couple routes we could go, but let's think about this in terms. Now let's start thinking in terms of our derivative. Okay. What is dy dx?
2x.
Okay, it's 2x. So if I'm hitting the point A, I know that that has to be what? 2a. So 2a equals the slope of my tangent line, right?
So 2a 2a equals the net slope.
Well, this is the slope of my tangent line as well.
Do you set it equal to the slope?
Okay, so yeah, we can set it equal to the slope. All right, and then once we figure out A, then we're able to plug that in, and we've got our equation. Okay, so notice here what we did, we have multiple unknowns. So what we were able to do is we expressed the slope of our tangent line in two different ways. One by using the derivative, one by using our slope formula.
Is that a limit? What's the arrow for?
What's the what?
The arrow.
I'm just saying this is the derivative of the function itself. That's going to give us, or yield, that yields a slope of the tangent line of 2a. Okay, so now I know, guys, that 2a is going to equal a squared minus 3 over a minus 2. And all I have to do now is solve that equation. All right? So 2a squared minus 4a is going to equal a squared minus 3. I've got a quadratic equation. Okay? Which actually means there are two possibilities, right? I got a quadratic equation. A squared minus 4a plus 3 equals 0. That means there's two different possibilities. The picture drawn shows 1, but there's another point up here that I could be tangent to as well. All right? So that's where I'm going to get the two different values for A. So if we factor this, we get A minus 3 times A minus 1. So A is 1 or 3. Okay? So check that out. Here's the 1, and here's the 3. Okay? So there are actually two different tangent lines to the curve that go through that point. Okay? Is everyone with me on this? Any questions here?
See that last one?
There are actually two different tangent lines that go through the point 2, 3 and are tangent to the curve here.
How do you know which one to use?
You could use both. You could give both. All right? If A is 1, then I have the equation y equals 1 minus 3 is a negative 2 over a negative 1 times x minus 2 plus 3. Well, that's just a positive 2. So y equals 2x minus 4 plus 3. That's the line y equals 2x minus 1. So that's for a equal to 1. All right? But then if I let a equal 3, I actually get y equals 9 minus 3 is 6.
Just 6.
3 minus 2 is 1, okay? Times x minus 2 plus 3. So 6, y would equal 6x minus 12 plus 3 would be a minus 9. So I have two different tangent lines. Okay? So, we find out actually, since this is the point A and A squared, we actually find out, hey, this is the point 1, 1, and then up here we have this other point, that's the point 3, 9. Okay? And those are the two different tangent lines. Okay? So. These take a lot of thought. You got to really think through everything you know, and notice how much we're drawing from previous knowledge too. Okay? Back here we're using synthetic division to divide stuff. Okay? We're using, even something as basic as the slope formula, but using that in combination with a derivative in order to get things equal to each other. Okay? So, this is some good problem solving taking place here. You just got to work on it. Okay? And that's why I've given you problems. I haven't given you as many, but we're a little bit out of time. But for example, when I'm giving you these problems, try to really take your time and work through, work through one like this, where you're meeting the curve again. And don't just blow through them, okay? So.